Well, good morning, everybody, and thank you very much for the invitation from ISNTD. It's good to see this series actually continuing. Last year, many of you would have been at the Natural History Museum for a similar kind of meeting. Now, I'm going to be a little bit of a gatecrasher here and almost an imposter because, in fact, we do not have new innovations for snail control. And that's my basic message, in fact, that we need new innovations for snail control and we need new molluscicides. Now, why is that? Well, many of you will know that the NTD scenario has changed completely over the last few years. We're now moving into a phase where optimism is high, where ambitions are great. So following things like the WHO roadmap and following the London Declaration on NTDs, etc., the scenario is changing. We're not just interested in morbidity control and rolling tablets out to people. We're talking now seriously about elimination of schistosomiasis. This is a map that we've recently put together in relation to elimination, and you can see that much of the schistosomiasis lies in Africa, in sub-Saharan Africa, where in some cases we don't even yet have a control program. Where you can see the light green in places, those are areas where we believe the disease has been eliminated. But the goal is, and by 2020, 2025, we need to change the whole of that global map into green. Well, how are we going to do that? We're not going to be able to do it just by the use of praziquantel. That's a drug that we use for treatment of schistosomiasis. We have to bring in other interventions. Some of those interventions have been used in the past, and they have been used successfully. So when we actually look at the data and look at the historical situation, we can see that snail control actually is needed where we go for elimination. In places like Morocco, Martinique, Egypt, and China, where schistosomiasis has been brought right down or eliminated, it's because we've integrated snail control with our chemotherapy. And obviously, no snails means no transmission. But where are we going? What's been happening for the last 20 or 30 years? Quite honestly, very, very little. We have got some new studies on biological control, which I'll touch on. Our group at the Natural History Museum with the Ministry of Health, we're using molluscicide in Zanzibar, where we're actually going for elimination of urogenital schistosomiasis. But we've got very old technology, we've got very old compounds, and the reality is, although people have been trained in Africa in the past, we've now actually lost that expertise for identification of snails and also the use of molluscicides. So how on earth are we going to meet these elimination challenges unless the vector control community responds to this situation and starts thinking about, well, what can we actually do to control these snail populations? And that's really why I've slotted myself in here into this session, to be amongst vector control people. I'm not a particular control person, but just to highlight the fact that we do really need to do something about this. One of the reasons that we're stuck in this situation is because of an old terminology. We talk about snails in trematode life cycles as intermediate snail hosts. For some reason, we don't talk about them as vectors, and because we don't talk about them as vectors, the vector community has forgotten about the importance of these snails or these mollusks in transmission. So what kind of things do we need to do to control snails? How can it be done? First of all, of course, we've got to be able to find the transmission sites, and we know that our distribution of these of snails depends on those environmental factors: temperature, current velocity, water chemistry, habitat permanence, etc. And we do know from a biological viewpoint that the snail-parasite interaction is very, very specific, is very local, so we need to be able to identify snails so we can identify our transmission areas. What has been used to kill snails? We've got one good synthetic molluscicide, a compound called niclosamide. Niclosamide is still available and produced as bailicide. I'll say a little bit about that. We have in the past had groups explore in great detail plant molluscicides. Some compounds from plants have been produced and gone into local agriculture and produced on a local scale, such as endod. But the reality is that we're way behind in terms of new formulations. We're way behind about thinking about the timings. Wouldn't it be lovely in some of these habitats to have slow-release substances? And wouldn't it be really good if we could link our treatments of snails to the transmission that's going on? And then we need to answer questions that if we are going to kill snails using chemicals, how long is it before these snails actually return? We can reduce snail populations by natural interventions. There's a lot of work being done on biological control. I'm going to say something about a new project in Senegal. We know a lot in the laboratory about the genetics of resistance, but looking at the compatibility between parasites and snails. We're getting down into the details of the genes involved with resistance, but goodness me, we're light years away from the kind of situation we've just so elegantly heard with the mosquitoes. But then, of course, we have to think again in terms of transmission. What reduction do we actually need in terms of population size, etc.? Change of habitat is something that we can do to control snails. We can try and remove vegetation because we know that snails like certain water velocities, etc. We can change water flow rate. And of course, we can try and create safe waters, safe areas which are not used by individuals. But I'll reiterate, it's a sad fact, we do not have any new molluscicides. Nothing's been developed or looked at in the last 25 years. That's a sad reflection, really, on our efforts to control this very important parasitic disease. Looking at plant molluscicides, as I said, we've had a number which are cheap, locally produced and biodegradable. That would seem to be a reasonable way forward. Ambrosia maritima has been used in Senegal. It's got a downside. You seem to need a very large amount of crude plant material to actually kill snails. This substance endod, which comes from Photolacca dodecandra, it's a saponin, did get to local production both in Ethiopia and Zambia. Yes, it kills snails. Toxicity reports have been done, but it also does have a wide spectrum of activity. If you go back into the literature, and my word, there's a big literature here. You find books on plant molluscicides, all of which has been lost from our research thinking. There is one plant which I pulled out, which actually was worked on by a group here at King's College, Molluscicida, which, if you look at the research paper, seems to be very good in that it's a water extract that seems to work very good against snails. It kills cercaria, most importantly snail eggs, and it has low fish toxicity. But nothing further has been done with Molluscicida as far as I can see. The compound that is used, niclosamide, produced by Bayer as bailicide, it's also produced in Egypt as molatox, and it's used extensively in China, and Dr. Lee might be able to say something about that in our panel discussions. It's used in the USA for controlling sea lamprey, and that's not an OCP slide, that's actually a picture of spraying in the States. But the use of this compound has fallen dramatically. I mean, so just looking at those figures, over the last decade, only 200 megatons of bailicide have been used in various countries, whereas in 1995, over 800 megatons were used in Egypt alone. So even with niclosamide, and there are promising things coming from China, we need some new formulations and we need some slow-release methods for use of niclosamide. It's got a huge downside in that it's not environmentally friendly. It's got a very broad spectrum of activity, so wherever you're going to use this compound, you're going to kill freshwater fish. If the freshwater fish are not important to the local community, you could argue that's okay, but if they are an important protein source, it's a huge disadvantage, and it's also very difficult to use in large water bodies, and because it's not used a lot and we don't have a lot of it, it's very expensive for large-scale use. But that's all we have, so that's what we're using. We have an elimination program in Zanzibar, which is a randomized intervention trial, looking at the use of mass drug administration with praziquantel. We're using mass drug administration and snail control, and we're using mass drug administration and behavioural change interventions to see what kind of impact we're having. And this is useful because we're beginning to develop expertise in using niclosamide in the kind of habitats we find on Zanzibar, and we're beginning to be able to actually help other countries come in and begin to use niclosamide for snail control. So that's becoming very, that's quite positive. It's early days, we're only in our second year, so I can't give you any real data on the impact of those different treatments. What about biological control? Well, biological control is always very fashionable at certain times, and we're all aware of the downsides of biological control. But with schistosomiasis, it's been absolutely amazing in certain parts of the world. It's certainly in the Caribbean and in parts of Venezuela, where different kinds of snails, prosobranch snails, Mauricia, tiara, and other snails have been introduced. They've had a huge impact on the presence and distribution of the intermediate snail Bionflaria glabrata. So that throughout the Caribbean, through the West Indian Islands, and parts of Venezuela, we've seen transmission come right down because of the sometimes purposeful introduction of competitor snails and sometimes by accidental introduction. But those snail-snail interactions are incredibly important, and in that part of the world, things have gone very well, and these biological introductions have been useful. As I said earlier, we know a lot about compatibility polymorphisms in snail-schistosome interactions, but we're fairly ignorant at the moment as to how these systems can be evaluated and how we can actually use them in the field. If we're going to use biological control, it's good to get some added benefits. People initially thought, well, fish, that's a good idea because we can use mollusk-eating fish for our purposes. We can also have an extra protein source. There are some places where that's been useful, but for the most part, it's only in closed ponds and irrigation systems. We get the converse in some natural water bodies, like Lake Malawi, where we've seen overfishing impacting on cichlids, reducing cichlids that eat snails, and we're having an increase in schistosomiasis because of it. Ducks have been talked about, and one particular project which is taking off at the moment is Project Crevette in Senegal, which relies on freshwater prawns. My colleague Elizabeth Huntinger, who's working in Senegal, provided me with the next couple of slides. This is a very interesting case in Senegal where there was a big water development. Dams were built across the Senegal River to stop salt water actually going upriver. What happened in the late 1980s was a massive epidemic, as you could say, of schistosomiasis, huge increase in schistosomiasis, both urinary and, well, initially intestinal and now urinary genital schistosomiasis coming in. And it was realized that one of the natural predators, a freshwater shrimp called Macrobrochrium, actually had almost declined declined in population level to a very low level because the dam had stopped the migration of the shrimp to the sea, and it needs to get into a saltwater environment to actually breed. Now, the wonderful thing about these river prawns is, in fact, that they eat a lot of snails because they're losing their carapace, that hard exoskeleton, very quickly as they develop over the first 6 months of their lives. They need to actually ingest a lot of calcium. So there's a thinking there that if these prawns could be introduced in that particular setting, that they could have some impact. And we can see from the couple of graphs at the bottom that Elizabeth's produced that our prawn sites seem to have a much lower prevalence than the control sites. And when we look at the idea of how can you actually manipulate and use these prawns, what they're doing in this particular area is actually netting off in small inlets of the river and keeping the prawns on one side, and so hopefully that's reducing the snail populations. And it seems, as we can see there, that what they're saying is, in fact, no infected blindness snails seen in that particular area since October 2012. So there's some benefit here for biological control. But of course, It's very local. You've got to be in a place where you can actually use the prawns, and there are different species that can be used in different places. And there can be a big downside about introducing prawns that don't already exist in the endemic area. Just to say something a little bit more about the snails, we are in a very good position for identification of snails. We're not as good as the parasite that's even better at identifying snails, but we can identify snails using different PCR approaches, sequencing approaches, particularly CO1 barcoding, ribosomal RNA spacers, etc. We do have good ways of actually identifying infected snails, PCR, highly repeated regions for both hematobium and mansni, and there's been some interesting work on LAMP for identification purposes. Just to put a plug in for the Natural History Museum as well, what we're trying to do with both snails and parasites is to establish a collection, a repository at the Natural History Museum funded by the Wellcome Trust. So we've got a developing collections of both parasites and snails, which are molecular genotypes. We're looking at population genetics of these organisms in different settings. And we're also interested, there's a little bit in the brochure that's gone around, actually developing this collection for other NTDs. And my colleague Aidan Emery's with us today, and I'm sure be happy to talk to people over the lunch break if they're interested in looking at ways that repositories and collections, samples can be stored, and collaborations that might be started. But we're right at the beginning. We've got a blank sheet of paper, really. How do we develop? How are we going to do it? How are we going to screen these molluscicides? How much time is needed? If we're talking about 2020 as a realistic endpoint, can we do anything? How are we going to fund this work? How are we actually going to get the regulatory approvals? And what would be an ideal molluscicide? It's got to be, obviously, toxic to our snails. Ideally, it would also kill our parasites, the Cercarian and the Myrissidia. Ideally, it would be non-toxic to other organisms in water. That's a big downside with niclosamide and with endod. They kill other organisms in the water. They're not particularly environmentally safe to use, and of course they could be having an unknown impact on the biodiversity in some of these habitats. There clearly needs to be safe in drinking water. There's a concern about niclosamide when you actually spray it in the water because of its bright yellow color, etc. But it has been used as a tenicide in the past. We would like our molluscicides to be long-lasting, and we would like slow-release formulations. Ideally, we would like these things to actually be active against snail eggs. If they could be locally produced and acceptable to local communities, that's going to be marvelous. Cost effectiveness, long shelf life, ease of application. All of these things you know better than I in the sense of vector control, but these are the kind of things that we need for our ideal molluscicide. So what needs to be done? Well, I would suggest we really actually have to go back and discover and develop new natural and synthetic compounds that have those kind of characteristics. There's a real need to, especially in the African situation, less so in China and places, but there's a real need to actually get a training component, a capacity building component in for snail identification, mapping and control. We're very good at mapping the distribution of schistosomiasis as a disease. We're pretty hopeless at mapping snail distributions at the moment. The other thing that we're going to have to do, and this applies to many of us, we need to integrate our snail control with vector control for other NTDs. We're very happy to give out tablets, ivermectin, albendazole, and praziquantel as an integrated program, but as yet down at the vector control level, as far as I can see, we're not very integrated. So our entomological colleagues go off and spray for mosquitoes, and if we do have a snail control team, it's a different working arrangement. I think we need to work with industry, whether it's niclosamide or something else, so that we can actually increase production and increase demand to reduce costs. Clearly, we need more modern technologies. We need to look at new formulations and delivery systems. It's unfortunate that Dr. Taib couldn't be here because in Egypt they're looking at the use of chlorophyllin for snail control as well as their mosquitoes. Yes, there's a role for biological control where possible. But when it actually comes to that 2025, 2000 or whatever, we're going to have to be able to certify interruption of transmission, both within the improving diagnostics within people and also looking for interruption of transmission within our snail population. So we've got to pay attention to that as well. And that will not allow me to go back to that slide that just flashed across the screen, which are the acknowledgements. So I would like to acknowledge the whole of the team at the Natural History Museum. I'd like to acknowledge the Ministry of Health in Zanzibar. I'd particularly like to acknowledge my colleague Elizabeth Huntinger in Senegal. I'd like to thank funding agencies such as the Wellcome Trust and the University of Georgia via the Bill and Melinda Gates Foundation. Thank you very much.